Okay, so in this video, I just wanted to run through a calculation that accompanies a vinegar titration. So I just picked 2016 question 1. Now, it might be helpful if you stop the video and actually open 2016 question 1, and then it's just basically the calculation I'm going to focus on here. Okay, so part A of that question, they asked you to describe in detail the procedure for dilution. Now, remember, we had 4 bullet points for that, okay? So if you're asked about the procedure for dilution, you're going to say that using a pipette and a pipette filler, that you measured out 25 cubic centimetres of the original vinegar and you transferred that straight into a 250 cubic centimetre volumetric flask, okay? Then what you would have done was that you'd have added deionized water until the bottom of meniscus of the solution was 1 centimetre from the graduation mark, and then you would say that using a dropper you add deionized water drop by drop until the bottom of the meniscus is at the graduation mark, okay? And then stopper and invert 20 times. Now we had the procedure summarised in our revision sheets, procedure for dilutions, and remember that procedure may also be asked in the bleach titration as well, so the same 4 bullet points. Now what's my dilution factor for this particular question? Well, if 25 to 250, so my dilution factor is going to be 10, okay? And the other thing they might ask you here is, why is it necessary to dilute the vinegar? Well, you're going to be putting the vinegar now into the burette here when you're doing the titration, and into the conical flask here, you're going to put your sodium hydroxide. Now, if you didn't dilute the vinegar, if you poured concentrated vinegar straight from the bottle into the burette, then literally the minute you opened the tap of the burette, your phenolphthalein would have turned colourless. Do you remember we spoke about number of moles of acid must equal the number of moles of base, when neutralization has occurred. And what will determine number of moles of solution? Volume times molarity, okay? So if the molarity of the acid is big, if you're using your concentrated acid straight from the bottle, then the volume is going to be very low. So your end point is going to be very, very low. So how will you start off that answer? Why dilute the vinegar? The original vinegar is too concentrated. So you're going to say that first. Original vinegar, too concentrated. Because the molarity is so big, that will result in a very low volume. Very difficult to carry out such a titration accurately, because the minute you open the tap, then your phenolphthalein has gone colourless. So it's very difficult to do that accurately. Alternatively, you could say, if you increase the number of moles of base, then that would mean you'd have to add more volume of the acid. So alternatively, you could increase the molarity of the sodium hydroxide. The only problem with that is that they don't want students using corrosive sodium hydroxide. So the concentration would be so good or so great that the solution would be quite corrosive. You could use a large volume of sodium hydroxide, but that's kind of wasteful. So the way they get around it is they dilute the vinegar first, so that you have to add more of it because the molarity is lower. Okay, so original vinegar too concentrated, which would result in a very low end point. Very difficult to do such titration accurately. And just before I get to the calculation now, phenolphthalein is your indicator, pink, PP, phenolphthalein, pink in base, colourless in acid. So just watch that spelling of phenolphthalein and just be mindful that it is phenolphthalein, not methyl orange. Okay, now, so part C now starts your calculation here. So the first thing they asked you to do is calculate the number of moles of sodium hydroxide in each of the 25 cubic centimetre portions. Now remember, you used a pipette to measure out the volume of sodium hydroxide. So the sodium hydroxide went in there into the conical flask, 25 cubic centimetres of it. Now the problem is, our first step to calculate the number of moles of sodium hydroxide, you need the volume times the molarity all over 1,000. You don't have the molarity. You have 1.2 grams in 500. So I'm going to do that down here. 1.2 grams in 500 cubic centimetres. So in a litre, that would be 2.4. I'm multiplying by 2 to bring it to a litre, and then divide by the MR of sodium hydroxide, which is 40. Will you please be careful to show the workings out of your relative molecular masses? So show that you're getting 40 for the sodium hydroxide. So when you do that, you're going to get a molar. When you do that answer is 0.06 molar. So that's the concentration of the sodium hydroxide. We know the concentration of the sodium hydroxide now, so I can fill 0.06 into molarity there. That's my M, the molarity of the base. So the volume is 25. We pipetted in 25 mils of the sodium hydroxide, or 25 cubic centimeters of the sodium hydroxide. The molarity is 0.06. I calculated that there, like that, okay? And now my number of moles is 1.5 by 10 to the minus 3 moles of sodium hydroxide in the 25 cubic centimeters. Is that okay? Then they asked you to calculate the moles of ethanoic acid per cubic centimetre. Now, will you stick with your steps? 1 is my number of moles, V by M all over 1,000. But remember, I didn't have the molarity, so I had to calculate that myself. Now my ratio is 1:1. Look at my balanced equation up here, 1:1. So I am going to need the same number of moles of ethanoic acid or vinegar, okay? So I'm going to need that number of moles of ethanoic acid. Now, equate, my third step then was I equate the moles to the volume. Now, 18.75 was the volume of ethanoic acid I had to deliver from the burette. Okay, so that's my equating my moles to volume. They asked me specifically in part C of the question, how many moles per cubic centimetre? I know that I have 1.5 by 10 to the minus 3 moles in 18.75 cubic centimetres. So what would I have in 1 cubic centimetre? Divide both sides by 18.75. And when you do that, you get 8 by 10 to the minus 5 moles per cubic centimetre. Okay, so that's that per cubic centimetre. Now, in the next part of the question here, which is part D, they then asked me to find the concentration of the ethanoic acid of the original vinegar. So I need to take my dilution factor into account here. The dilution factor was 10 because it was 25 to 250. Now, I know that I have, just from my previous answer there, look, I have that many moles, 8 by 10 to the minus 5 moles of ethanoic acid per cubic centimetre. So what would I have in a litre? Because I want my answer moles per litre now, okay? So in a litre, multiply by 1,000. So in a litre, I would have 0.08 moles per litre. But that's the diluted vinegar. So how will I get the concentration of the original vinegar? Multiply by 10. So when I multiply by 10 there, then I'm getting 0.8 moles per litre, and that's the original or the concentrated vinegar that was in the bottle, okay? That's my answer to part 1. Now for part 2 of D, they asked me to calculate that as percentage weight per volume. Now remember, what does percent weight per volume mean? It means so many grams, percent, always 100, and V means cubic centimetres. So I'm going to have to go from moles to grams. I currently have 0.8 moles per litre, but I need to go to grams. It's ethanoic acid. So show the working out of the relative molecular mass of ethanoic acid, and it's 60. So multiply that by 60 and you're going to get 48 grams per litre. But you want grams in 100 because it's percentage, look. So you have to divide by 10. So you're going to get 4.8 grams in 100 cubic centimetres. That's your answer to the question. Okay, now in the last part of that question they asked you, starting with the primary standard of anhydrous sodium carbonate, what 2 titrations would be required to standardise sodium hydroxide? So that's what I was doing in the previous video. So you would have to, firstly, you would have to use your anhydrous sodium carbonate against your HCl. That'd be your first titration. That would standardise the HCl for you. And then in the second titration, you would use the standardised HCl with the sodium hydroxide, and that would then standardise the sodium hydroxide. And then you could use that to calculate the concentration of the vinegar. Okay, thank you.